This question asks us to see if a graph is bipartite or not. So the input of this question will be a 2D array, and the output will be a Boolean that represents whether the current graph is a bipartite or not. So let's say the assumption we have. So the assumption were that there were no self-edges. That means that each of the array in that 2D array will not contain itself, and which itself refers to the current index they have. And there were also no parallel edges. That means that each of the array in the 2D array will not contain duplicated values. And also it is an undirected graph. And finally, the graph could not be connected in some sense. So we can have like two nodes that are either like there were no paths between them. So for example, if there was this graph right here and we have a node number 4 and node number 4 does not connect to anybody, so that's also a legit things to think of. So the solution to solve this question is to use the BFS. And we are gonna firstly BFS starting from each of the nodes and then traverse all its neighbor and all possibly connected nodes to see whether it is a bipartite graph or not. And if it is already being visited, we mark it as visited, and we saw if there's a conflict between that visited node and the node itself. So if there's a conflict between the groups, then it is not bipartite. Say if we mark 0 to a color to a group of U, and then we mark its neighbor to a different group by the property of bipartite, so we will have U right here and 1, 2, 3, which is the neighbor of 0, to be in the V group. And then we do the BFS, we put 0 to out, and then we try to see 1 here, and then we see that if we found a conflict, so we BFS all its neighbor of 1, which is 0, 2, and we found a conflict because although 0 is already in the being assigned a group which of U, which is the contrary side of 1, but 2 is in the same side because we want 2 to be the group of U, and 2 has already been given the group V, so it is a conflict. That means that our graph is not bipartite. And we can do this example by assigning UV to different group, which means that we can have the bipartite, because we can have 2 and 0 be in the U group and 1 and 3 in the V group. So nextly, we look at the code. So we will take a 2D array and output a Boolean, and we have a hash map that record the group that has been assigned for those nodes that have been visited from some routes of BFS. So for each of the nodes, we do a BFS. And so in our BFS helper function, it basically starting from the index, which means the node index. So we do a BFS to all its neighbor. So we firstly take the graph, 2D graph, and we take the map, which records the neighbor that it has been visited, and we also record the current starting node that we are doing BFS for. And if the node has already been visited from the other routes that we have tested whether it's a BFS or it's a bipartite or not by other graph, if we have already visited that, we do not need to visit them again. And then we try, if they have not yet been visited, we just put, starting from that node, we put that in a queue, and we put that current node in the queue, and we mark it as visited and assign it to the group of U. And we do the BFS starting from the index node. So we found firstly put out the index node and find all its neighbor, and also we assign the color from that new node pulled. So that color should be the neighbor's color should be different from the current node's color because it's a property of the bipartite. And then we just trying to test all the neighbor from the current node. So we see if we have two cases out of that. So if the first case will be the node has not yet been visited, so we will just assign a color to that neighbor node. And the other case is the neighbor node has already been visited, so we will place a different, we will test if there's a conflict or not. If there are a conflict, then we will not go to further testing and we will just return false because it means there were not a bipartite. And if we found that there were no conflict, then we can just test to see other neighbor of the current node pulled out will have any conflict or not. So if no, then we return true. And so if all the nodes that passed the test of the BFS, that means that for each of the node, even they were disconnected, and with BFS always know we do not find any conflict. So that means the graph will be bipartite. So we just return true. So one of the big takeaway is that firstly, we need to traverse starting from each of the node because it is the graph may not be connected. So we must go through from each of the node in the graph to do a BFS and traverse all its neighbor. And the second bug or the second mistake that I've taken false is that for this one, if the graph has already been BFS'd in the other path, starting from its neighbor or its parent node, we call it. So then we do not need to do the BFS again because it has already been assigned a group, and we had already through the other paths of the BFS we had already make sure that they will not be the conflict route. So then so we see the time complexity of this question. So because we traverse each of the each of the nodes at most once, so we will have V plus E as our time complexity, and the space complexity we were having an extra space, which is the visited hash map, which is of the time complexity of space complexity of V, and we have the maximum capacity of that hash map will be the number of vertex, so it will be OV, and also the Q, the maximum size, will probably won't be as much as V, so the space complexity will be just V. So this is all I had, and thank you for